Hello everyone, my name is Ahmed Inaya, and in this video I will talk about MAC addresses and ARP. Let's start by talking about the need for physical address. IP address represents location for device, not the device itself. So for example here, we have these two networks, 10 and 12. If device IP address starts by 10, we know it is in this location, and if device IP address starts by 12, we know it is in this location. Somehow, IP address represents the location, not the device itself. IP addresses can be dynamic using a protocol called Dynamic Host Configuration Protocol (DHCP), which we will discuss in the coming slides. This protocol makes IP addresses assigned dynamically in the network, and there is no static IP address configuration in this case. So for example, this device when connects, it can get 10.0.0.1 IP address, and when it disconnects and connects again in another day, it may get another IP address which is 5. So the IP address may change from one time to another using protocols like DHCP. IP address is logical, not physical, which means if you move a device from one network to another, the IP address will change. So for example, for the same device here, 10.0.0.5, if we move this device to the network 12, and if you connect it here to that network, this device will get a new IP address 12.0.0.4. So the IP address for this device changed when it moves from one location to another. So there should be a way to identify the device itself, not its location, and this physical address should be universal and unique per network hardware. And this is why we need MAC addresses. So what is a MAC address? MAC stands for Media Access Control. MAC address represents the physical address for network hardware. It is 48 bits, which means it is 6 bytes or 6 octets, and it is divided into two parts. 24 bits as OUI or Organizationally Unique Identifier. The other 24 bits are assigned by vendors and they are unique per interface. So this is the format in binary. As you can see here, this format is very long because we have 48 bits, which makes it very difficult to read. 24 bits are for OUI, which identify the vendor for that hardware or device, and the other 24 bits identify the interface, and these are assigned by the vendor. So this address is very difficult to read and very difficult to memorize or recognize, and that's why usually we use hexadecimal to represent MAC addresses. This makes these 48 bits MAC addresses represented as 12 hexadecimal digits. These digits are also divided into 6 digits as OUI and 6 digits as interface. So this MAC address here can be represented in this format, which makes it much easier to read and understand. MAC address goes by many names like burned-in address, and this is mainly because manufacturer usually burn this address into the hardware, and it is decided during manufacturing process and burned into the hardware. It is named also as Ethernet address, and we will discuss Ethernet protocol in the coming videos. And sometimes it is named as hardware address because somehow it represents the hardware itself. There are three types of MAC addresses. Unicast MAC address, which is similar to the MAC address I mentioned in the previous slide. These MAC addresses represent single hardware. This address may represent one PC, one laptop, or any device in the network. Actually, this address represents single network interface that's connected into the network. MAC addresses can be multicast, which means they represent a subset of all devices in the network now, and we can identify these multicast MAC addresses by looking into this bit in binary format. This is the last bit of the first octet, and if this bit is 1, this means this MAC address is multicast. Otherwise, the MAC address is unicast. So if a MAC address has 1 in this bit location, this means it is a multicast and it is for a subset of all devices and not for a single device in the network. The third type of MAC addresses is broadcast, which means all devices in the network now. So if the traffic is sent to this MAC address here, this means all devices in the network will receive this packet, as we will see in the coming slides. The format of a broadcast MAC address is all F or all ones. So in binary, this is all ones for 48 bits. So if the MAC address is all ones in binary or all Fs in hexadecimal, it means this MAC address represents all devices that are connected now to the network. So for devices to map IP addresses with MAC addresses, they need Address Resolution Protocol or ARP for this mapping. So why this is needed? It is needed mainly because applications and users communicate using IP addresses, while devices in the same network communicate using MAC address. So there should be a protocol or should be a way to map IP addresses with MAC addresses in the same network. So for a device to get MAC address for certain IP address, it sends ARP packet, as we will see in the coming slide. ARP packet has a broadcast MAC address in its header, which is all if hexadecimal or all one binary. To understand ARP more, let's take an example. Let's assume we have this network here, which is 10.0.0/8. Devices in this network are all in the same subnet, so they are 10.0.0.1, 2, 3, and 4 for different hosts. The MAC address for each device ends with the two letters represented here. So MAC address for this device ends with AA, MAC address for this device ends with BB, MAC address with this device ends with CC, and the MAC address for this device ends with DD. Now let's assume this device here, AA, which has the IP address 10.0.0.1, wants to communicate with this device here, which has the IP address of 10.0.0.3 and MAC address that ends with CC. As this device doesn't have the MAC address for this IP address, it sends a packet to everyone asking who is 10.0.0.3. The protocol used in this case is ARP, so this host here created this ARP packet with FF in the header, which means this packet should be sent to all devices in this network. Within this packet, it sends the ARP inquiry, which says what is the MAC address for this IP address 10.0.0.3. Once this ARP packet is sent, it will be received by all devices in the network, including 10.0.0.3, but as it is a broadcast, it will be sent to all devices in the network, whether they are 10.0.0.3 or anything else. For devices that are not 10.0.0.3, they simply ignore this message. So for example, this device here, it reads inside the packet. It finds that this packet is looking for 10.0.0.3, but as my IP address is not 10.0.0.3, I should ignore this message. The same applies to this IP address here. It is not 10.0.0.3, so it simply ignores this message. The only device that processes this message is 10.0.0.3, so when it looks inside this message, it finds that it is an ARP inquiry looking for MAC address for the IP address 10.0.0.3. So this device, as it is 10.0.0.3, it replies to this message with ARP response. This ARP response is sent as unicast to the sender device, which ends with AA, and within this ARP packet, it says that the MAC address for 10.0.0.3 is CC, which is the MAC address for this device. Now host A knows exactly where is 10.0.0.3, and it knows the MAC address for this device, which is CC. So it adds in its ARP table a new entry that says 10.0.0.3 is CC. Every device in the network has an ARP table that map different IP addresses to MAC addresses. So when device A sends next packet to CC, it doesn't need to send ARP packet. ARP packet is sent once per session, and it is added to the ARP table to avoid sending multiple ARP packets for the same communication channel. But after some time of inactivity, this ARP entry will be removed from ARP table, and after removing this entry, host A needs to send another ARP packet if it wants again to communicate with CC or any other device in this network. ARP entries can be added manually, and in this case we call them static ARP entry, which is not common. Usually it is preferred to keep ARP entry dynamic to accommodate for any change or any movement in the network. So how to find your ARP table? Let's assume you have Windows 10. It is very simple. Just open CMD from Start menu and type the command ARP-A. This command will show you all ARP entries that are active in your device now. If you enjoyed this video, please like, share, and subscribe to my channel to receive future videos. Thank you and have a good day.